Hi, welcome back to Math with Patrick. Today is January 18th, and we have yet another problem to solve from this Daily Epsilon calendar. Let's try it out. Looks like it's another geometry problem, and we're solving for this area of the rectangle. And what we're given is this bottom side length. It is 3 times the fourth root of 2. And we don't know this vertical length, but if we did, then I could do base times height and get the area of this rectangle. So I guess my goal here is to figure out this vertical length. Maybe I'll get this one, or maybe I'll get that one. And when I do, then finding the area won't be that hard. And ultimately, the area is supposed to be 18 because that's today's date. So Quill and I will do a little bit of thinking. I'll get back to you on what a good strategy for this is. Well, I actually don't have a good strategy just yet, but I did notice a few things. First, this distance right here is, 3 times the fourth root of 2, but it's also the radius of the circle. So any of these distances also are 3 times the fourth root of 2. Second, I noticed that this diameter of the small circle is going to be equal to the radius of the big circle. Or in other words, the radius down here is half the size of this. So I know that this distance is 3/2 times the fourth root of 2. And I guess from knowing the radii, if I look at it kind of in a specific way, if I line it up here and then I line it up here, I'm drawing a straight line from one center to the other. And so that's just going to be the two radii added to each other. So if I really wanted to, this diagonal length is going to be 3 plus 3/2 times the fourth root of 2. And so that's going to be 9/2 or 4.5 times the fourth root of 2. So again, not really sure where this is leading me, but I at least have this new length that I could use in my triangle, and it's this diagonal between the two centers of the circles. Okay, little recap. This radius down here of the big circle is 3 times the fourth root of 2, and the small radius is half that size. And I actually noticed something in the pause where this length d, I wrote d for diagonal, is a hypotenuse of a right triangle. And not only that, but I also have one of the legs, as in I have one of the side lengths adjacent or next to that 90-degree angle. And that's just that small radius, R2. So here is R2, this is the length d, I know both of those, and with the Pythagorean theorem, I can solve for the length I don't know. So it looks like I do know the hypotenuse, that's going to be d, and then it doesn't really matter which one I label A or B for this R2, so I'll just pick A. So R2 squared plus this height squared, I'm calling it height because it's this vertical distance on the rectangle, is going to be equal to d squared. Looking above, R2 is this value, so I'll go 3/2 the fourth root of 2, squaring that because of the formula, plus h squared, still don't know that, equals d squared, and that's going to be 9/2 times the fourth root of 2, also squared, and that's just coming from the Pythagorean theorem. Okay, to simplify, I'll start with this square, and just kind of by the definition of what squaring means, I'll write out this times itself. And when I multiply stuff together, I'm allowed to do it in any order. So I'll grab these two together and then deal with those fourth root of 2's later. A little bit of fraction multiplication, I'll multiply the 3's on top, then the 2's on bottom, and get 9/4. To multiply these two fourth roots together, I'll just talk about what the definition of a fourth root means. It just means that if I take the fourth root of something and multiply it to itself 4 times over, I will get to that number underneath, in this case 2. Kind of works the same with square roots, where I just need 2 of them together to get the number underneath the square root sign. And actually comparing these two equations, if I group it like this, you can kind of see how the fourth root of 2 times the fourth root of 2 should get me the square root of 2. And that's what I'm going to put right here. I still don't know what h is, so I'll keep it as h squared. And I'll simplify the right side in a similar way to how I simplified the left part of this equation here. All right, now I should just keep solving until I can figure out what h is. I'll subtract this term and move it to the right side of this equation. So I'll get 81/4 times root 2, and I'm subtracting 9/4 times root 2. And here I can tell that I could like factor out a root 2 and just worry about the fraction subtraction right there. 81 minus 9 is going to be 72. So h squared is equal to 72/4 times root 2. 72 is a multiple of 4. I know that 20 times 4 is 80. So I could do 18 times 4 to get 72. It's just, two fewer 4s. So this 72 over 4 is just going to be an 18. And I should square root both sides to get h alone. And this is a little bit gross, having like square roots inside of square roots. I could distribute that square root sign, and then the square root of the square root of 2 is going to just get me the fourth root of 2. And I could simplify this root 18. I could find its factors. 3 times 3 times 2 is the same as 18. And I know that when I have a buddy, they can hop out together. At least that's how I think about simplifying square roots. So I have 3 times root 2 times the fourth root of 2. A quick algebra note, when you have a variable squared that equals some number and you hit both sides with a square root, you do typically need a plus or minus sign. That's just because looking back at the original equation up top here, I could take a -2 and square it and get 4. Or it could have been positive. And I don't really know, so that's why I do usually need to consider both options. But since I'm working in a geometry problem, this distance, it's just going to be positive. I can throw out the negative potential answer just because distances are just kind of always positive. I guess unless you're in a physics class and the direction matters, but it's not physics here. And I know that this distance, I can just call it positive. And this distance is very important to find my x. X is the area of this rectangle, and I know I can do base times height to get the area of a rectangle. The height is just going to be, well, h, and I solved for that earlier. And I will substitute in, 3 times root 2 times the fourth root of 2. And the base is going to be this original distance that we were given at the very start. 3 times the fourth root of 2. Got it. So I can tell from earlier, I could combine these two to get a root 2. And why not? Let's combine these 3's together right now and get a 9. And I'll just drag and drop this root 2. Finally, I can see that these two root 2's together create a whole number 2. And finally, I know that 9 times 2 is 18. Ta-da! There we go. So the area of this rectangle indeed is 18, and it matches today's date, so we're all done. Cool. Well, we did some more geometry, walked through the Pythagorean theorem, did a lot of fraction and radical algebra here, and ultimately we can confirm that the area is 18. Thanks for coming along. As always, it's great having you here, and I'll see you in the next video. Bye-bye.